Hello everyone, welcome to Sulfursoft. Today we are going to start tutorial number 13 of Python Mega Course. In this tutorial, we are going to discuss the most important concept of Python programming language, which is mutability, immutability, and reference variable. It is not so much difficult, but it is important to clear the concept of Python programming language. Future videos will also depend upon this concept, so it is important to clear this concept right now. Otherwise, it will be difficult for you to handle the future videos or to learn the future videos. I am clearing this concept in a very easy way. Let's start. Simply, mutable mean changeable and immutable mean unchangeable. We will also discuss mutable, immutable, and other concepts of this video through practical examples. Just understand right now that mutable is changeable and immutable is unchangeable. Here we are in the pie chart. We are declaring a variable a is equal to 10. The data type of this variable will be integer because we have declared the value as 10, which is whole number. One thing must be noted that in Python everything is an object. What is object? What are classes? These all concepts will be discussed in object oriented videos of Python programming language. Let's suppose we have declared a variable a is equal to 10. Whenever a variable is declared, then Python virtual machine will look into the memory that that object is available in memory or not. If that object is already not available, then Python virtual machine will definitely create an object in the memory. Let's suppose we have declared a is equal to 10. Now I'm going to show you through a diagram that how Python virtual machine creates an object. This is for example a space or memory. Python virtual machine will look into the memory that whether the object with the content 10 is available or not. If it is not available, if it is not available, then Python virtual machine will create an object. We have declared an object with the value 10, for example. Now Python virtual machine has allocated a memory space to this object. There will be an address of this object as well. How to access the address of this object we will see also. A is basically the reference variable which will be pointing toward this object like this. This is A and it will reference toward this object. The meaning of this line, if we represent in the form of diagram, then meaning of this line will be this. A is the reference variable, 10 is the object, and A is referencing toward the object 10. Consider it just like home. A home in a colony has an address. How to access the address of this object? We can access the address of this object by printing the ID of this reference variable. We will print the ID of reference variable A to check to which address this reference variable is referencing or pointing. So this is the address. We are copying it for better understanding. The address of this object is this, and A is referencing toward this address. This is what this line is showing. Now I am declaring B is equal to 10. Although both variables are different and we will be thinking that separate object will be created. No, this is not the case. As already we have discussed, whenever a variable is declared, then Python virtual machine will look into the memory that whether the object with the same specification is available in the memory or not. If the same object is available in the memory, then it will not allocate a specific and other memory for the other object. Instead of it, it will refer this variable toward the old object like this. Reference variable B will be pointing toward the same object 10 like this. As we have already discussed that Python virtual machine will look into the memory that whether that object 10 is available in the memory or not. If it will be available, then the reference variable which has newly been created will be referring toward the same object. The main advantage of this concept is this: the memory utilization become very much minimum by utilizing the already developed object. Let's print the ID of B, whether this reference variable is referencing toward this object or not. We are using the same function ID on the reference variable B. Look at these two addresses, and these two addresses are clearly showing that the both variable are pointing toward the same object. Hence, memory utilization will be minimum. But there is one problem. If we want to change the content like this 20, then the content of both reference variable will be changed, which is not suitable or which is not required in the programming. If we want to change A, then only A should be changed instead of B. But if we will change this, then both reference variable value will be changed. This is not what we want. Once an object is created by the Python virtual machine in the memory, it will remain same throughout the entire life. For example, now we will change b is equal to 20. Then what will happen? Now the address of both reference variable is different. Why? Because Python virtual machine has looked into the memory that whether 20 is available or not. And when he looked into the memory, then 20 was not available. Hence, the Python virtual machine created another object 20. And this variable changed its reference toward 20. Instead of changing this, we have created a new object. This is called immutability concept, that once an object has been created, it will remain unchanged throughout the life. Till now, we have used id function to check whether the address of one variable is similar to the address of second variable. Now, we will utilize is operator to check the similar thing. How is operator can be utilized? Let's see. For example, A is equal to 10 and B is equal to 10. Both reference variable will be pointing toward one object, that is 10. If we want to check that whether the reference variable A is pointing toward the same object as B, we can use is operator as well. Print A is B. True mean A and B are same and pointing toward the same object. Only the name of these reference variables are changed. Now we will discuss further data types to check whether they are mutable or immutable. Let's discuss. In Python, int, float, boolean, string, tuple data types are immutable type data types. Whereas built-in objects like list, set, dictionary, they are mutable. Till now, we have covered int, float, boolean, string data types in previous videos, and in upcoming videos, I will be discussing on tuple, list, set, and dictionary type data type. But here, to understand the concept of mutability and immutability in these type of data types, I will give small touch of these data types as well. Let's discuss on the pie chart. We have already covered integer type data type in the concept of mutability and immutability and concluded that int data type is immutable data type. Mean once it has been created, its type and its address will remain the same. If we want to change it with the 20, then the object will remain the same, only the new object will be created. Now I will take float 10.0 for example, and it is 20.0. Whether A is B? Yes, true, A is B. And now I want to check whether the address of both reference variable is similar or not. Address of both reference variable is similar, hence float data type is also immutable data type. If I will change it like this, A is equal to 10.0 and B is equal to 20.0, then what will happen? Look at here, the address has changed and A is not equal to B. A is not B. Similarly, we will take string data type like Henry, and here I'm also using the same. True. A is B, true, and the address of both variable is same. It means string data type is also immutable data type. If I will change it as Henry1 or Henry John like this, then it is false. A is not B. ID is also different. Hence, string data type is immutable data type. Now, I will take complex number 5 plus 6j for example, and similarly I will take it as 5 plus 6j. True, complex data type is immutable data type. A is B, the address of both is same. Now I am going to change it as 7j. False. Now I am going to take a tuple. To define a tuple, we use small brackets and variables are segregated with commas. We are going to discuss tuple type object in upcoming videos. We define the tuple like this, and now I'm going to take another tuple 1, 2, 3, whether it is mutable or immutable. True. Once it has been created, it will not be changed. And other reference variable with the similar tuple will be referencing toward the old object instead of creating the new one. We will discuss list, set, tuple, dictionary in upcoming videos. Now I am taking list. To define a list, square brackets are used. False. Look at here. A is equal to 1, 2, 3, and the similar type of list has been defined by B. B is equal to 1, 2, 3, but both reference variable are pointing toward the different location. The address of both is different: 50257480, 51725480. The address of both reference variable is different and A is not B. It is showing whenever we will create a list, whether the contents of the list are same inside it, but Python virtual machine will create separate variable. Similarly, if we want to take set, set is defined like this. Again false. Again Python virtual machine has defined separate objects. Instead of pointing toward the same object, Python has created different object even the content in both the objects are same. A is not B and the address of A is not equal to the address of B. Now we are defining the dictionary and we are going to discuss the mutability and immutability of dictionary. Dictionary is defined in a form of key value pair like this: key, and there is a value of that key, key, and there is a value of that key. Similarly, I am going to take another reference variable like this, and both reference variables are same, but the Python virtual machine has created different object for both the reference variable. A is not B, id of A is not equal to id of B. Hence, we have proved that int, float, boolean string, tuple type data types are immutable, and objects like list, set, dictionary, these are mutable.